All right, so we've already sort of drawn this analogy between water flowing through a pipe and charges flowing through a wire. And we make these geometrical arguments about, well, if the area of the pipe is bigger, then the resistance is lower. And that turns out to be true for electricity as well. So we can think about this electricity-water analogy further. So if we say we have this circuit here with a certain potential, and our source of potential in this water pipe will be a pump, or in this case, it's like a paddle wheel that's spinning around and causing water to flow in this direction. And in a similar way, the battery here is causing charges to flow in this direction. So the battery sort of acts like a paddle wheel, that I have these charges that come off of here, and when they come off the battery, they have a very high energy. The energy is very high. And as they go through the circuit, they lose their energy doing whatever it is that they do. So it'll go through this resistor, and it'll heat up the resistor, produce light, or cause a motor to turn or something. And then when it comes back, it has a very small amount of energy. And that's true here, that the water has a very high amount of energy. And then as it goes through and does whatever it is it's supposed to do, when it comes back here, it has a very low amount of energy until it goes through the paddle wheel again and causes it to boost up its energy. All right? So the battery then acts like a paddle wheel, and it increases the energy of the electrons or the water, however you may want to look at it. When you have resistors in parallel, it'll look like this. So here I have an object with big resistance. This is a big R. I'll make it bigger, huh? And this is a little r. Okay, and then here's the paddle wheel over here. Which of these pipes is going to get the most current, or which of these pipes is going to get the most water flow? I have this source of potential coming through here, and then when it comes to this point, the water can choose to go two different directions. It can either go in that direction, or it can go in that direction. Well, obviously the water is going to, more of the water is going to go through the bigger pipe because it shows less resistance. And that's going to be true for the circuit too. So I will have a higher current here than I do up here. Up here I have a lower current because that has a greater resistance. Right? So the pipe or the resistor that gets the most current or water flow is the one with low resistance. And we'll see that come up in the next chapter when we deal with the resistors in parallel and series. Now let's do our final topic, which is electrical energy and power. Now, batteries convert chemical energy